an hour long, and I've split it up into 4 sections. We're really going to cover 4 different topologies. And just to ground ourselves, I'm just going to say a few things just so we know the basic region we're in, and that's we're in the region of supervised learning, meaning all of our data is labeled, right? So labeled data, representational learning, meaning we have layers. Each layer, each new layer is a high representation of the previous layer. So the previous layer may be about edges and color. The next layer may be about eyes and ears and nose, and the one above that tries to group them together, and then finally we have some kind of decision boundary. So that's the area we're in. And the way we learn is through back propagation of errors, right? So we're descending down to a local minima, and eventually the network will converge. So those are the foundations, regardless of topology. Whatever topology we consider, those are the foundations. And I hope that you're aware of those basic foundations of how we learn in a deep learning supervised mode or semi-supervised mode. So basics. So as I said, we'll cover 4 topics. The first one is, it's called split, transform, merge. It's actually reduce dimension, split, transform, merge, which gives us reduced parameters, because in 2012 and 2013, we had networks like AlexNet and VGG, that had 60 million parameters, 3.3 gigaflops for AlexNet, and for VGG we had 135 million parameters, and it took like 30 gigaflops to be able to inference through that, right? So these were pretty large networks, and for things to get practical, we need to start to reduce them, right? So that's topic 1. Topic 2 is residual connections. So instead of direct mappings, we're going to try to see how residual mappings help us go deeper, okay? We'll say more later. And then now the next 2 are about topologies for application-specific domains. One is segmentation, and how do we use a encode-decode kind of a network to segment. And finally, how do we do some similarities through twin networks, Siamese twin networks that essentially are the same network sharing parameters. And then I'll show you some code, because that's how we ground ourselves, through code. I mean, we can talk a lot all day, but code is where we ground ourselves. And the idea is to give you some basic building blocks.